there was hardly any power system analysis software, let alone that was open source, let alone one with a nice user interface. So I think you'll show us that today the world has changed and it's changing.
Thanks a lot. So my name is Santiago. I'm the CTO of a startup that's coming from the Polytechnic University of Barcelona. And we do software for power systems and consultancy. And they adopted the program that I started 10 years ago. And now I became the CTO. So you know the route to the C-suite is that, make open source. So if I need to think of a description of what a modern power system software is one that it tackles all the typical things that I need to be a power systems engineer. And that would be wave phenomena, electromagnetic phenomena, electromechanical phenomena, thermodynamic phenomena, and political phenomena. So I need to, go full stack. Usually, this wave phenomena is tackled through EMT, electromagnetic transients simulations, and they are being asked when something wrong is going on, usually in connection studies. Also, RMS will be the root mean square of that, and then power flows, and then planning, and then so you get all of these. So if we think, at least this is stuff that influenced me personally, if we think of a landscape of tools that tackle pieces of these problems, we can go as far as 1960 with EMTP. Then PSDC is a software that now is owned by Siemens, has 70% of market in TSOs. Power Factory is a tool made in Germany. It's a great one. It's one of the few ones that tackles the whole thing. Then Mad Power, I would say that everyone doing any modeling today is because of Mad Power. And then stuff that happened over the years. For instance, PSAT, I would say, is the other one that tried to tackle everything by Federico Milano. And then I started something in 2016 that was GridCal, and now it's called VeraGrid, and you can ask me later why. And yeah, I just put the Python stuff. I know there's also other softwares in Julia and so on. So if you need to ask what is a good design, it will be something that doesn't change when the conditions change. So this is my first release in 2016, and here's the current release in 2026. You see there are many differences, but there's some things that are still there. I can tell you right away that the backend is unrecognizable from one to the other. And from that process, what at least that I know, I've refactored all the software 7 times. Refactor means kill everything and start, because there was something, that was smelly, that wasn't allowing me to advance. Kill and start over, and don't be afraid of that. That would be my tip 0 if you want. So this talk is about giving you tips of how to develop such tools, such that they survive and they eventually tackle the whole thing. So the number 1 tip is make it read-only. I know this might be a bit cryptic, but in computation, every time you create something in memory and you go back and try to change it, the computer says, expensive stuff. So that's a bit of thing it's hard to realize of that. I realized of this one writing a C++ engine, and by not respecting this, I was capping 30% of the performance. So every time you have a database, once the user writes it, keep it that way. Once you start a simulator, keep it that way. Once you write the results, keep it that way. That's fast. This one is let the objects flow. This implies that I use objects in contraposition to using tables, which is what most people use. And an object is nothing but a table that the things inside the table can be more tables. Right? If you think it like that, so objects can point to other objects. So if you run typical simulations like optimal power flow or something linear, you don't really need to be that flexible. You can use tables. But there's a simulation where the user is going to tell you the equations. It's not you, the programmer, the user is telling you. And for that, you will need a symbolic framework that you will need to link to the stuff of the real life, like a line, a load, a generator, and the equations tell how those objects behave in real life. And you as a programmer cannot tell those equations because they're infinite equations. So you need to be a bit flexible and, again, use objects instead of tables. This is looking complicated already. So if I'm making a software with objects, that an object is a foreign concept for most power systems engineers. And I'm already telling you that everything should be objects, and objects inside objects and stuff like that, then how do I make it simple? Then I put a graphical user interface on top that is dummy proof. Everything that you click shouldn't crash, you know? And it should be more or less what power systems engineers are used to, right? So let the GUI handle the workflows. Don't worry so much about if your interfaces below are kind of complicated to the average user, if the interface is going to be this. Of course, this is the hardest part of the whole project. Making something that looks like this and works and everything, and how to represent the structures in such a way is what took me the most time to figure out. Great, thanks. Refactor now or pay later. If something is not really fulfilling what the users expect or what you think should be, there's a refactor going on. Back when I was working at the Spanish TSO, we had this model. This is Spain, Portugal, and France. And this model was taking, so it was a couple of years of data and so on. So everything in the model could change, not only the loads and generation, everything. So status of things, switching state, many things. And it took 63 gigabytes of RAM in the program at that stage. So I started getting complaints like, man, we have 8 gigabytes laptops, we cannot work with this, but we have to work with this. So 63 is a big number. What if we drop the 6, right? We just remove the 6. How's that looking? So what I did was taking many big tables again that were before there, and many things were repeated. If you compress those tables with zip, those tables compress to 3 gigabytes. The challenge is to replicate that zipping process into something that you can edit. So we came up with something called a hybrid profile that is dense and sparse. And because of that, people can do this, the planning of Spain with my software in a DSO because of this kind of innovation. Another thing, it will be design by layers. What does that mean? It means that you don't need to tackle all the interfaces in the same interface. That would sound stupid, you know? But of course, you don't have to do it. A typical example of this is that a line can come in something called per unit parameters, or it can come with ohm parameters. Electric engineering stuff, but it can come with way 1 or way 2. Don't need to tackle both at once. Tackle one of them, and the other you support it through a function. Simple stuff. Going deeper in the design, I have a database, and then I have something called numerical data, which is views of the database that are very fast for computation. And in fact, getting the view of the database is a copy operation, so it is very cheap. In contrast with going through arrays and stuff like that, that's very expensive if you don't do it right. And you do topology processing, which is usually very expensive to do on a database. You do it on data, it is snap, then simulation, then results. By layers, everything. Then about files. A file is whatever it is in the memory of a program, saved to disk. That's the simplest way of thinking about it. But then, what I say is that this file, usually a memory dump, is a contract between past and future versions of the software, right? So I say, write, then parse. So I take my memory, whatever it is in the program, I make an interpretation, I save it to disk. Right now, the VeraGrid files are a zip file with JSONs inside. This was the fastest way of getting information at the time. And then parse it back. And with this contract in mind, today I can read the files I was creating 10 years ago. 10 years ago, I was using Excel as a file format. You know, really bad. But I can read them today because of this thing. Many simulations, many formats, one product. There is a paper from the 1960s that says how committees invent. It is incredibly relevant today because it essentially says that any person or organization, when they write software, they replicate themselves and structure in the software. So if you want to know how am I inside, I'm a star pattern, and I tried my company to be a star pattern too. Because what I want in the end is to have a software that is not one simulator for one method. I want a simulator for all of the methods. So I make it such that it is a system that allows methods to come in this star pattern. And with this I conclude. Questions, please.
5 minutes for questions.
Yeah, great. Don't be afraid.
What GUI library do you like to use?
Qt. Yeah. Oh, what library do I use for the graphical interfaces? So it's Qt. I've regretted many times, but now it's more stable, so I like it better.
Is it open source, and how do you fund the development?
It is open source. I started with a GPL library, a GPL license, then an LGPL license, and then I switched it to a Mozilla license. And how do I fund it? By working, the first 8 years of this, I funded by just going home and do it. Eventually, with time, I convinced my managers at companies that this is the way, so I managed to do things at work. And now it's the same. We fund this by making it work for people, by being a viable replacement, by the way. So now we go to TSOs and we show them this stuff, and they don't have like a hard time getting into the program. Question is how much adopters is VeraGrid? So I would say, well, from what I can measure, there are like 1.5 million downloads, something like that. Adopters, I don't know. You can check by the downloads, but yeah.
How do you enable collaboration between multiple people using this software?
So the question is, how do I enable collaboration? That's a hard question. And what I'm going to say is a bit opposed to what you would like me to say. And so I force them, So when people come to collaborate with this, I tell them it has to be super high quality, it has to be object-oriented, it has to be clean, it has to be efficient. So all these tips I said. Some people chicken, some people don't chicken and continue. The people in my company, when we hire, I make sure that they know what they come for. And for external people, I make sure that they know what they're up to. Yeah.
Sorry, I was not talking about the development process itself, but if you have the software and you seem to be focused on the desktop user,
yeah.
If you have multiple people who they
Oh.
share files,
Exactly. Great question. So how's the collaboration in the software itself? So right now we do it through something called deltas. And essentially the database that we have is differentiable. So you can compute differentials, and then you can join those differentials. And that's how we are working in my company right now. People doing different stuff, and then we merge. And there's a conflict and all sorts of stuff like that. So the question is, if we have a piece of code that handles symbolic code, yes, we do. And in fact, we didn't use SymPy or anything like that because of a practicality. That is, in SymPy, if you declare A or B 2 times, for SymPy it is the same variable, but for using in this, it has to be different variables. So we went all the way to developing a symbolic framework that can handle differential equations.
How do you assess the conformity of the topology you're using in the software?
Question is, how do I assess the conformity of the topology? You mean that if someone writes something, that it is actually connected?
No, is it conform to reality?
Oh, to reality. So question is, if it conforms to reality. My answer is, I don't care. My answer is, I don't care if it conforms to reality. Bad answer maybe, but this is a power system model, so it should represent a power system. If it later represents the reality, that's fantastic. You can have coordinates and represent it in a map and everything, but up to you, up to the user.
Do you find that users also contribute to the software?
The question is, if I find that users contribute to the software less than a 10%, and the reason is the one I gave. The entry barrier seems huge for people in power systems, but I cannot lower the bar. It is what it is. Time's up. Thank you.